Welcome back. A very good morning, good afternoon, good evening to all of you. And as you know, this is the DADM 2 course under the NPTEL MOOC series, and we are in the third week, and this is the 14th lecture. That means with 2 lectures, 14th and 15th, we will wrap up the third week. And as you know, this course is for 12 weeks, which is 60 hours. Each week we have half an hour, such 5 lectures, and after each week we have an assignment. Till the 13th lecture we discussed about the concepts of utility and how you can consider utility for different things. I will come to the decision trees later on, but first I would like to start off with the concepts of data and development analysis as a concept, then come back to solving problems accordingly. Now, so this is a PDF file, so I will scroll down, so please bear with me. So consider you have a system. So system is basically any unit which takes some input and basically gives some output, and consider those units are called the decision making units. Example can be hospitals. So Apollo hospitals, if they are at different parts of the country, so in Mumbai, in Kolkata, in New Delhi, in Chennai and Bengaluru. So if you have different units of Apollo, so they will be considered as decision making units or DMUs as mentioned in the first line. Or it can be, say for example, the state government of different states, Maharashtra, then it can be Chhattisgarh, Uttar Pradesh, West Bengal, Odisha. So we will basically consider that as some decision making units. It can be in school also, or it can be the IITs also, all like Kanpur, Delhi, Bombay, then IIT Madras, IIT Kharagpur, or it can be the IIMs also. So you have some decision making units, and what are the inputs? So say for example, for the hospital the inputs can be nurses, can be paramedic staff, can be doctors, can be number of beds, can be different type of services which are given, OPDs, it can be either related to gynae, it can be related to some cardiac related treatment, whatever. And the output can be, say for example, the occupancy rate of the beds. So lower the occupancy rate, better, because people are being they are recovering and then going out of this nursing home. So how rate the people move out from the system. It can be the number of successful operations, it can be number of successful cases, critical cases handled. It can be, say for example, also be the number of very sophisticated operations which are being done. And in the case of, say for example, the IITs and IIMs, the inputs can be students, can be teachers, can be staff, can be the library, can be the infrastructure, computer, classrooms, labs, and the output can be quality of students who are working in different types of sector of the country. It can be how well they are placed later on, what is the average salary packet, how many are going for higher studies, how many are going for research, how many are joining government services, how many are starting their own businesses. Or it can be how the IITs and IIMs are able to help the people from the lower strata of the society get education. So it can be different things. Say for example, for the government, inputs can be government servants, input can be, say for example, taxes. The output can be, say for example, the quality improvement of sewage system, quality water, then traffic problems are eased out, crime and law and order are minimized. So they can be different outputs. Whenever you are considering this in DMUs, the inputs and outputs need not be in quantitative terms, need not be in terms where you can basically quantify in rupees, in dollars, in yens. Say for example, I want the number of students to graduate from the university, so it will be only numbers. Or inputs can be, say for example, the library, or output can be the salary, or median salary, average salary. So for the salary we have some values, for the library it may not be quantifiable, it may be more qualitative. So with this, let me read it. Consider you have a system, or also called a decision making unit, which takes some inputs, a bundle of inputs, processes them, whatever the process is. So, for example, if it is a CNC machine, it is taking the raw material, it is taking the cutting fluid, it is taking the electricity, it is utilizing the man hours of the worker who is working on that. So, they can be different things, and output can be different type of HP motors which are being produced, can be the scrap material which is to be sold in the market. So, they can be different type of outputs. So, let me continue reading it. It processes them and produces some outputs. So, we will denote inputs by IPs and outputs by OPs. Example of such systems or DMUs can be, as I mentioned, as machinery, a factory, a hospital, an airport, and university. Invariably, there may be many such similar systems, like if I am talking for the example for the IITs or the universities, can be all the IITs. So, they are each single DMUs. If you are considering the government, or each state is a DMU. If you are considering the airport example, it can be would be the different type of airports which you have in India. So, invariably there may be many such similar systems or DMUs which takes as inputs, which is the same types of inputs in different quantum, in some of and gives the outputs in different quantum. It may be possible that in some of the machineries which you are utilizing to produce, say for example, different HP motors, some of the DMUs may not produce those DMUs. So, obviously, we will produce those type of motors, we will consider them to be 0 in that case, but we will consider bundle of inputs and bundle of outputs as the output and inputs as IPs. So, invariably there may be many such similar systems or DMUs which take as inputs and the same types or sets of inputs IPs in different quantum, process them and produce the outputs also in different quantums, in different numbers. So, in such a situation we are required to find that what is the rate of processing of these inputs and outputs, or what is the efficiency of the DMU. So, what is the efficiency would be considered relatively, that means how good or bad is DMU 1 with respect to DMU 2, or how good or bad is DMU I with respect to DMU j. So, we will basically compare the efficiencies of the DMUs and say that where the improvements can be done. So, in such cases we are required to find what is the rate of processing of these inputs and outputs, or what is the efficiency of the system. I am just repeating the statement, so that we can compare them against themselves, that is the DMUs, and compare against themselves and find out to what degree they are deficient when compared with the ideal system, or in what respect they are efficient when considered with different other DMUs which are there. So, obviously, there would be two ways of comparing. One would be the way of when you are trying to compare the absolute scale and the one with the relative scale. Say for example, I will give an example which may not make immediate sense. Say for example, you are okay, let me consider we are doing the marking of DADM 2. So, obviously, many students obtain different marks. So, we can consider, or generally what is followed is there can be two marking scheme. One is the relative marking scheme, one is the absolute marking scheme, or absolute scale, relative scale. In the relative scale, the highest marks is, say for example, pegged up to 100, and then basically the grading found out, and based on 80 would be in. So, say for example, 80 is made 100. So, proportionally the person who gets 70, his mark is made, his or her marks is basically pegged up to that relative scale. Similarly, a 40 marks student, his or her marks would be pegged up to that relative scale where 80 has been made 100. So, this is the relative scale. Now, obviously, the relative ranking would be given. In the other case, and obviously the grading would depend, because you have already decided on the brackets of the grades depending on the marks. Now, when you come to the absolute scale, so we will consider the absolutely marks, whatever it given it is as it is. So, if the person has got 80, it will be considered 80 out of 100, and you will basically peg the marks or the grades of the other students accordingly to an absolute scale. So, to first explain that, let us explain the problem in a more systematic manner, and let us assume the following. Number 1, M is the input numbers. So, there would be 1, 2, 3, 4 till capital M. Capital N is Nagpur, say for example, is the number of outputs. So, 1, 2, 3, 4 till capital N. You have K number of DMUs. So, 1, 2, 3, 4 till capital K. So, what I am basically highlighting are these. So, this is basically an user. So, this is M is the number of inputs, So, you will basically have the inputs as going from 1 I is equal to 1 till capital M. J would basically be the output, so it will be going from 1 to capital J, and K would basically be the number of DMUs. It will go from 1 to capital K. So, M and J, okay, sorry, my mistake. So, this would be, so this would be till N. So, capital N, M, capital N and capital K need not be equal, obviously M and N need not be equal also. So, we will denote X suffix ik as the ith input variable for the kth DMU. So, we basically have the DMUs 1 to capital K. So, for each one they would be the inputs. So, we will consider I number of inputs are there, I can be any number. So, you will basically have x11, x12, x13, x14, so on and so forth, where the first number will denote what is the number of the input, and the next number that is 11 or 12, that 1, 2, 3, 4, which is the second number would denote what is the DMU size. So, basically x11, x12, x13 would basically denote the first input for all the corresponding DMUs 1, 2, 3, 4, 5, 6, so on and so forth. So, you can basically do it in the other way also by doing the nomenclature as x11, x12, x13, where the first number basically may denote the DMU also. Similarly, you will basically have yjk, where it will denote the jth output corresponding to the kth DMU. So, again similarly y11, y12, y13, y14 will denote as per this nomenclature the first output with respect to the first, second, third, fourth, fifth and so on and so forth DMUs. Or if you follow the policy where the first subscript denotes the DMU, then basically you will denote it as y11, y12, y13, y14, so on and so forth, where the first number 1 would denote the DMU and the next number 1, 2, 3, 4, 5, 6 will basically denote the output. And obviously the outputs and inputs and the DMUs would be denoted by the maximum number N, M and K. We will also denote UIKs and VJKs as the ith input for the kth DMU and the jth output weight. These are the weights. So, U and V's are the weights. So, VJK is the jth output weight for the kth DMU. Again, you will basically have U11, U12, U13, so on and so forth, where the first number will denote the input number and the second number 1, 2, 3, 4, 5 as per this nomenclature denotes the DMU. It can also be reversed in the sense you can consider x11, x12, x13, so on and so forth, where the first number 1 denotes the DMU and the second number 1, 2, 3, 4, so on and so forth denotes the input. So, obviously, you can basically make that differentiation accordingly. Similarly, when you have V11, V12, so on and so forth, as per this nomenclature, the first number denotes the output number and the second number 1, 2, 3, 4 denotes the DMU. You can also reverse it, where the first number would denote the DMU and the second number would denote the output. Now, let us consider, let us highlight here. So, let us consider 3 different concepts of production and scales of returns. So, that will give us the picture why we are trying to do the formalization of the optimization problems accordingly. We will come to the solution later on. So, let us also consider 3 different concepts of production and returns, which are number 1, increasing return to scale IRTS, decreasing return to scale DRTS, constant return to scale CRTS. And we will see that how these 3 returns to concept would in turn change the basic formulation of the optimization problem, even though the final methodology based on which we will try to solve the problem, the simple optimization problem concept would remain the same for all the 3 cases. Added to that, what we said is basically this increasing, decreasing and constant return to scale. We will have three different type of models. One is the output oriented model, one is the input oriented model, and one is the radial model. We will consider the combinations of the output and the input coming into the picture. So, output would have some implications, input would have some implications. So, the output word means some implication with respect to the output, input means some implication with respect to the input, and radial measure would basically a combination of them. So, let us consider this graph. So, this is the decreasing returns to scale. So, which is highlighted here is me okay. I think I should use the. So, this is the decreasing return to scale. Let me decreasing return to scale. So, this is the decreasing return to scale which I have just highlighted. Now, let us look at the graph. So, first note down the y axis and the x axis. So, on the y axis you have the output, on the x axis you have the input, and the graph which gives you the combination of the output and the input is, which I will again highlight now using, say for example, the light pink color. Let me use another color. Let me continue using the yellow one. So, it will be easy because yellow one is not here. So, the graph is this one which he highlighted. Now, notice one thing, notice the black one DME 1 which is mentioned as inefficient, because the set of all the DMEs which are combination. So, why I am saying that? Okay, let us consider arbitrarily, whichever it is, but consider arbitrarily a point is here, a point is somewhere here, and there is a DMU. Now, if you consider the input is here, the output is here. Now, if I am looking at the bundle of input and output, what I would basically think? There can be two ways. One is at the same level of input or output, I will basically try to minimize or maximize. It's in this way. Consider there are other sets of DMUs which are scattered. So, let me use this as the set of points. So, I am using so these are the set of points which are there. All the points which are there are DMUs. I am just taking as example. I will erase this later on. So, consider the point which is here, which is just vertically up. It means at the same level of input, the DMU can get an higher output, which is here. I just very lightly mark it because I want to erase it later. So, rather than this point, I would rather go to this point where my output would be more. Consider other way around. I want to basically keep the same level. So, here I keep the input fixed, increase the output. Now, on the other hand, consider the output is fixed, but the input is very high. So, what I will do, I will try to go. So, in this case, I will try to go up, and in the later case when it is horizontal, I will go more onto the left, such that at the same level of output I will try to basically utilize less and less input. So, that means I am always trying to move up vertically up and onto the left horizontal. So, if you consider this, so now I can erase this set which is there, which I have drawn. So, if you consider the point which is the black one, this is inefficient, which means it can go vertically up, which means we are following the blue line, and it touches this point which I have not drawn, and this is marked as DMU efficient output, bracket output, what I am going to come to that. So, this is in blue color, and or else I can go on to the left horizontally, which is the pink line, such that I reach the DMU 1 which is efficient, but with respect to IP. So, IP is the input and OP is the output. So, what it actually means is this. So, actually it means that this DMU 1 which is inefficient can be made efficient with respect to the input also or with respect to the output also. Another way this inefficient can be made efficient is to move in such a way diagonally such that it reaches that curve which was there. So, the curve why it is decreasing, in the sense this decreasing return to scales concept is basically, it means that as you keep increasing the input, the output increases, but the rate of change of the output starts decreasing. That means the first derivative is definitely, if you remember the utility concept, the first derivative is positive, but the rate of change of the second derivative is basically less than 0. That means per unit, each unit addition of the input, you are getting a little bit less and less amount of output correspondingly. So, if you move, so if the curve is there where I am hovering the pointer, and if I move diagonally and such that I move the least distance diagonally such that I am tangent to the point where I reach, which is basically here, which is marked by OPE and IPE, which I am just marking with the my pointer. So, that point would basically be the point where both the input decreases and it may also mean that the output can also be increased. So, that I am trying to basically make a compromise where the input decreases in some proportion, output also decreases in some proportion, but the overall efficiency is the highest, such that in some cases it may be true that I have to decrease the input, but at the same time I have to increase the output or decrease the output proportionally in order to maintain the maximum efficiency. Now, let me consider very simply hypothetical examples. Consider the vertical movement up. You have employed 10 workers and 3 machines. Now, it so happens that these workers you cannot be fired because they are permanent workers. But on one hand, you have purchased 3 machines, very sophisticated machines, each be costing, say for example 20 lakhs. So, in that case, what on an average price, and in that case it will mean that you will basically have to increase the production in order to increase the efficiency, because you cannot decrease your input, because decreasing input means what, you have to basically lay off one of the workers, which obviously mean a huge amount of litigation cost, or you may basically not try to increase the production, but tell them to sit idle. But if they sit idle, obviously as they being permanent workers, you have to pay the salaries, the medical bill, the insurances, the provident fund, electricity costs which you are incurring, and so on and so forth. On the other hand, so obviously a rational decision has to be taken whether you will go vertical up. Consider the case where you want to basically move horizontal left, and in this case consider that you are taking temporary workers, that means you can hire and fire them as per the norm. So, if you have taken temporary workers, say for example on one day you need 20, so you will hire 20, keep them for 1 month, say for example suddenly see the production is falling down and you want to maintain the same amount of several output, you may basically give each person who is working a little bit more, but basically reduce the number of workers we are coming, so as that, or we are employing. So, out of the 20 number of temporary workers, you may be in a position to, say for example, tell 7 of them that they need not come for the coming days, and you will basically pay the salary to the 13th one and do the work. So, obviously it can be done accordingly. Now, the right choice which you do for the decreasing return to scale, when you have this choice to make, so the best one would be that either you can go up or you can go on to the left horizontally, or you can go diagonally. So, diagonally means that you are trying to compromise on both the concepts of the efficiency side. So, the nomenclature is, what you can do is that output oriented is given as I mentioned as the blue color, input as the pink color, and the radial one as the green color. So, remember the distance of the DMU inefficient, which is the green, the black one, which I am just trying to hover, not mark, till the radial one, which is the green diagonal point. So, this distance would basically be the minimum, which would is the shortest distance which you are going to consider. Now, consider the decreasing return to scale, but the axes are inverted, in the sense you basically consider the input one along the y axis and the output one along the x axis. So, obviously in that case the graph would be as input decrease. So, in that case input orient in this decreasing return to scale, the case was that as you increase more and more on the input, the commensurate increase in the output is not happening. So, if you keep increasing the inputs then outputs, then the curve would just be the mirror image, inverse one with respect to the case where you had the outputs along the y axis and the inputs along the x axis. So, in this case again that set of DMUs would be on the upper side of the curve. You can either move vertically down or you can move horizontally onto the right. So, they are basically being shown vertically down means the pink one, same thing. So, it is you will move down such that you are decreasing your input, but trying to maintain the output, and in other case you would basically move on to the right, that means you are maintaining the same amount of input, but trying to increase the output. And the radial case you will try to move the least distance radially such that you are tangent to the curve in order that you are able to decrease input and always make a compromise on the output also. So, this increase and decrease would depend on the type of problem you are doing such that you are trying to increase your efficiency. Again the nomenclature is the same thing. In the green line is basically radial one, the pink one is basically is input oriented where you only concentrate on the input, the blue one is basically which you only concentrate on the output, that is why it is known as the output oriented. And the again the same nomenclature of the distance from DMU which is inefficient till the tangent point is the least one, which is straight line. Now consider the increasing return to scale. So, in the increasing return to scale you will consider the graphs again in the same way. In first case you will consider the output along the y axis and the input along the x axis. The graphs are such that as you keep increasing the input, the output would increase, but in a higher proportion such that the rate of change of the functional form output input is positive, but the second derivative would be higher. That means per unit as you keep increasing, the addition of the output is happening at a faster rate. So, all the set of DMUs, if you consider the inefficient one, if you go vertically up, which is which becomes this is the pink line, there you basically maintain the same amount of input but increase the output. If you go horizontally left, there you basically maintain the same amount of output but decrease the input, and the radial case you basically try to increase the output and decrease the input in such proportion that you get the best combination. Again the same type of examples which I gave would be applicable. And here the green line which is the radial one would be such that it is a tangent which is a straight line. The nomenclature is again the same. And for the output oriented model it is the blue one, the input oriented model is the pink one, and the green one is the radial one. And if you see the distance, the right choice would be the pink one because you want to basically do the case where the increasing return to scale is there. So, because increasing return to scale means that as you keep increasing the input, the output also increases, but in a higher proportion. In the other case, when it is decreasing return to scale, it will be if you keep increasing the input, it is not it is going to increase, but it is going to increase at the lower scale. So, in the next class I will discuss the increasing return to scale, but with the axis is inverted, in the sense the input comes into the y axis and the output comes into the x axis. With this I will end the 14th lecture and continue the discussion of DE in more details, at least the discussion, and then come to the formulation once we complete few simple optimization problem. Have a nice day and thank you very much.